Hi, this is Flip Math Exponent Rules by Jordan and Eric, and what we're going to start with today is the power rule. And the power rule says that when raising a power to a power, all you do
when we pause
is multiply
You read this and then I have to explain
I'll do this. Oh, you guys get closer to the
exponents.
Okay. Ready, set, go.
What is the
And again, it's a rule that makes solving stuff
multiplying numbers with the same base that have
easier.
exponents? And how
Okay, well, if you don't know power rule, and I want you to copy these down on Cornell notes, looks a lot like this. You get an example like this. If we're going to multiply the exponents, all you have to do, and you eventually get to the 12th power. And if you keep multiplying them, you get these. Now, the third one, I want you to pause it and do it on your own. And what you're going to do is standard and exponential form. So, standard would be like, the actual answer exponential would be that. And next is the quotient rule.
Here, you guys want me to write it?
And that says that when dividing
No, we have to write
two powers with the same base,
x3 to x4
To X5.
Okay, x3 to x4.
you can subtract the exponents.
No, we erase this because we have to answer.
Wait, you guys get out at 207.
Okay.
And that says why. Some of you are probably thinking, why does this work the way it does? Well, since when multiplying two powers with the same base, you add the exponents, it makes it subtract with dividing. And again, like when you're doing this, like something like that, 2 to the 5th power divided by 2 is the same as the 3rd because they get you the same answer eventually. And a common mistake would be dividing exponents instead of subtracting, just like over here, a mistake would be multiplying adding the exponents, not multiplying. And then, some examples on the back. What you do is for subtracting them, if you're doing 4 to the 3rd minus 4 to the 2nd, well, if you subtract them, you just get 4 to the 1st, which is the same as 4. And then 8 divided by 4, you get 8 to the 4th. And then for the last one, again, I want you to pause it and write your answer in standard and exponential again. Next would be product rule. And that says that when multiplying, can you see the pen? Multiplying two powers of the same base, you could add the exponents. And then common mistake would be multiplying the exponents instead of adding them. Some examples of this, which is problems, if you're adding them, 5 plus 8 is 13. 8 plus 2, it would be 10. And then 5 plus 2, that's your problem. I want you to pause and solve 3 in standard and exponential again. And once you go back and do Then comes the zero rule, and that states that any number with an exponent of 0 is always 1. And it's like, why? It's like, just a second, it'll make sense when you do examples, I promise. A common mistake would be thinking that the 0 exponent is the same as a number with a 1. And as you can see, I'll do this real fast, 2, 0 equals 1, and 2 to the 1st power equals 2. So they're never the same. And what I do is that I do it with a pattern, because I always thought that was easier for me. And since you start with, well, let's cross it out for a second. Since 2 to the 2nd power is 4, 2 to the 3rd power is 8, what you're always doing is multiplying by 2. And so if you're trying to get 1, well, it makes sense if you multiply 2 to get 2 squared. So all you do is divide by 2, and that would get you 1. and that gets you, if that gets you 1, then it just makes sense, you know. And it's like, I will not make you do examples because it's a good waste of paper, just like this note I wrote down there. Now, next we'll do the negative exponents, and that states.
Are different too this year compared to last year. I know we have different kids,
And that states that any non-zero number raised to a negative power
where in other grades and other subjects
it's reciprocal raised to the opposite.
They started with
What? It's like when we're subtracting polynomials, you can change the power to its opposite and get the same answer. Well, how do I find the opposite? Well, if you wait, it'd actually be helpful if I could tell you. Sorry, it's okay. And so, example will be 2 to the negative third. If it's 2 to the negative third power, what you do is you change it to reciprocal. So it's 2 to the negative third equals 2 to the negative third over 1, which should also equal 1 over 2 to the third power. So if it's 1 to the third 2th power, that is your answer, and 2 to the third power is 8, so it's 1 over 8. And then 5 to the negative second power is 5 to the negative second over 1, which equals 1 over 5 to the second, which equals 1 over 25. And as some of you also don't know, this also equals 1 point. That also equals point. No, wait, scratch that, never mind. But as you can see, these are all simplified to a decimal, never a negative number. So it's 6 to negative 5. I want you to do on your own, but just write it in exponential. Now, a common mistake is thinking that when x squared is a number, the x negative squared is the opposite of the answer. So write down here, 2 squared equals 4. So you might think that 2 to the negative second power is also negative 4. That's not right, because whenever you're doing a negative, it's the same as dividing the number, so it's a part of the whole, not, it would equal a decimal and not another negative number. Now, before we get to the challenge questions, I want you to do a summary. I don't care how much you want to. In my class, if it was my class, it would be a formative grade. But since it's not, just bring in the summary and then do your challenge questions for extra credit.